You stand in Lebanon's Bekaa Valley staring at 3 stones. Each one weighs 800 tons. That's 1,600,000 pounds. Placed 20 feet in the air with millimeter precision. No mortar between them, no cracks, no movement in 2,000 years, despite earthquakes that leveled cities. The Romans built a temple on top of them around 60 CE. But here's what nobody wants to say out loud. The Romans didn't cut these stones. They found them already there. The foundation beneath Rome's grandest temple in the empire isn't Roman at all. It's something older, something that doesn't fit. Welcome to Baalbek, where 12 mysteries challenge everything you thought you knew about the ancient world. 3 in the temple foundation called the Trilithon, 3 more still sitting in the quarry 900 meters away. The Germans found the largest one in 2014 buried under debris. It weighs 1,650 tons. That's the weight of 3 Boeing 747s fully loaded. Nobody moved it. It's been there since someone carved it from bedrock and then walked away. If you value documented engineering history and archaeological mysteries like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual using sources from the German Archaeological Institute's 2014 excavation reports published in their bulletin series and peer-reviewed studies from Jean-Pierre Adams' 1994 volume Roman Building, materials and techniques from Indiana University Press, which provides detailed analysis of Roman construction methods that definitively show these megaliths exceed Roman capabilities. Now, back to the information. That's the western stone at Jerusalem's Temple Mount placed under King Herod around 15 BCE. Herod was connected to Baalbek. His masons used identical techniques at both sites. The T-shaped podium at Baalbek matches his Jerusalem terrace walls exactly. But here's the issue. Even Herod's engineers stopped at 520 tons. The Baalbek stones are 54% heavier. No Roman crane could lift 60 tons. That's documented. The strongest Roman lifting device was the polyspastos crane. Multiple ancient sources describe it. 6 to 10 ton capacity maximum. Chaining multiple cranes together sounds good in theory. In practice, the system collapses. The math doesn't work. Modern engineers calculated you'd need 40,000 men to move 1 Trilithon block using ramps and ropes. The problem is spatial. An 800-ton block measuring 62 feet long by 14 feet high by 12 feet thick doesn't offer enough surface area for 40,000 men to grab. The logistics are impossible. You can't fit that many people around a single stone. And here's what makes it worse. These stones were transported uphill from the quarry. The temple site sits higher than the quarry by several meters. That means lifting against gravity. The stone of the pregnant woman in the quarry weighs 1,012 tons according to 1996 geodetic measurements by Austrian surveyors from Linz. It never moved. The stone of the south, discovered in the 1990s, weighs 1,242 tons, also never moved. The forgotten stone found in 2014 weighs 1,650 tons. Never moved. Someone cut these monsters and gave up, or didn't need them, or couldn't move them. Pick your theory. None of them make sense with Bronze Age or Roman technology. Modern laser scanning in 2015 confirmed this. Deviation across 40-foot length measures in single millimeters, not inches, millimeters. The Romans used chisels, bronze and iron, copper for softer limestone. James Harrell and Per Stormier published research in 2015 showing ancient Egyptian quarrying techniques with copper chisels over 50 centimeters long, used from 1500 BCE onward. Similar marks appear at Baalbek. But here's the problem. Achieving millimeter precision across 19-meter spans with hand tools requires something beyond skill. It requires a level of planning and measurement that shouldn't exist. The blocks aren't just placed, they're fitted. Each Trilithon stone has a slightly beveled edge that locks into the next. No mortar needed. The weight alone creates the seal. This technique appears at other sites. The Acropolis Foundation in Athens, the Temple Mount in Jerusalem, but nowhere else at this scale. The largest foundation stones at the Giza pyramids weigh 80 tons. The Trilithon blocks are 10 times heavier. The precision is tighter, and there's no explanation for how it was done. Tool marks on the stones suggest copper or bronze implements. That's standard. What's not standard is the uniformity. Every cut is clean. Every angle is exact. No mistakes, no do-overs. No practice runs visible in the quarry. Whoever cut these knew exactly what they were doing, and they did it once, right, then moved on. Why leave them? The Romans completed the temple by 60 CE. A graffito on one of the Jupiter Temple's column drums dates to August 260 CE in the Julian calendar. That's confirmation. The temple was standing, columns were up, decoration was ongoing. But the 3 largest stones ever quarried by human hands stayed in the ground. The stone of the pregnant woman has visible quarrying marks. Wedge holes line its edges. The extraction process was underway. Then it stopped. Why? The standard answer is the stone cracked. That's partly true. There is a fracture, but the fracture runs horizontally through the middle. It wouldn't have prevented use. The stone could have been split into 2 400-ton blocks. still manageable by the same methods allegedly used for the 800-ton Trilithon, but nobody did it. The Stone of the South and Forgotten Stone show no cracks. They're clean, ready to move, but they never moved. So either the Romans didn't know these stones existed, or they knew and couldn't move them. Both options are problematic. If they didn't know the stones were there, then who carved them? If they knew and couldn't move them, then the 800-ton Trilithon blocks become impossible. You can't claim the Romans moved 800 tons, but gave up on 1,000 tons. The scaling doesn't work. The effort difference isn't that extreme. If you have the method for 800, you have it for 1,000, unless the method wasn't Roman. This was noted by multiple researchers, including Graham Hancock in his 1995 work, Fingerprints of the Gods. The limestone of the Trilithon has surface weathering consistent with long exposure, centuries, maybe millennia. The Roman columns and decorative elements sitting on top of the same platform are clean, sharp, no erosion. They were carved around 60 CE and protected by roofs and courtyards. The Trilithon sat exposed. For how long? The difference in weathering patterns suggests the foundation predates the temple by a significant margin. How significant? Weathering rates for Lebanese limestone in the Bekoe Valley climate have been studied. Dry summers, cold, wet winters, occasional snow, wind from the west. Under these conditions, limestone erodes at roughly 0.1 to 0.3 millimeters per century for exposed surfaces. The Trilithon shows erosion depths of several millimeters in some areas. That puts the exposure time at over 1,000 years minimum. But the Romans built the temple around 16 BCE, when Baalbek became Colonia Julia Augusta Felix Heliopolitan. So if the Trilithon was already weathered in 16 BCE, it was carved significantly earlier. Bronze Age, maybe earlier. The problem is, there's no Bronze Age culture in Lebanon with the capability to move 800-ton stones. The Phoenicians were master builders. They built the Temple of Solomon in Jerusalem. King Hiram sent his son Hiram Abiff the architect. But Phoenician construction methods used smaller blocks. Dressed stone, fitted precisely, but not at megalithic scale. The largest Phoenician blocks weigh maybe 20 tons, not 800. So who did it? Ancient world. These blocks measure 11 meters wide. That's 36 feet. They form a U-shaped base that wraps around 3 sides of the temple platform. The western wall, where the Trilithon sits, rises 7 meters above ground. That's 23 feet. The 350-ton blocks are at the bottom. Then the 800-ton Trilithon, then Roman construction on top. The whole platform measures 88 by 48 meters. That's 289 by 157 feet. The surface area is 4,224 square meters, over 45,000 square feet. All of it sitting on megaliths that shouldn't exist. The foundation blocks were cut with the same precision as the Trilithon. Same tight joints, same beveled edges, same weathering patterns. They're part of the same construction phase. But here's what doesn't make sense. If you're building a foundation, why use 350-ton blocks when you could use 35-ton blocks? The structural benefit is minimal. Stone is stone. Weight distributes the same whether it's one big block or 10 smaller ones. In fact, smaller blocks are easier, more forgiving, less risk. If one cracks, you replace it. With a 350-ton block, there are no do-overs, so why go big? The only reason is to prove capability, or because the method you're using makes size irrelevant. Neither explanation fits Bronze Age or Roman technology. Not one Roman text mentions how the Trilithon was built. Not one inscription names the engineer. Not one coin commemorates the achievement. This is the largest temple in the Roman Empire, bigger than the Temple of Jupiter Optimus Maximus in Rome, bigger than the Temple of Artemis at Ephesus, built on the most impressive foundation ever constructed, and Rome is silent. The only contemporary mention is from Macrobius, writing around 400 CE. He describes the temple's golden statue of Jupiter, beardless youth in a charioteer's garb, right hand holding a whip, left hand holding lightning bolt and wheat ears, but nothing about construction. John Malalas, a 6th century Greek historian, claimed the temple was built during Antoninus Pius's reign from 138 to 161 CE, but the graffito on the column drum proves it was standing by 60 CE. So Malalas was wrong, or describing renovations. Either way, he says nothing about the foundation. The silence is deafening. Rome was proud. They built things to last, to impress, to intimidate. Moving 800-ton stones 20 feet in the air and placing them with millimeter precision is the ultimate flex. Why not brag about it, unless they didn't do it, unless they found it already there and built on top? That fits the evidence better. But it creates a bigger problem. Who built it before Rome? Margarete van Es and Klaus Wright from the German Archaeological Institute published research in 2012 showing the megalithic platform uses a different measurement system. The dimensions are close to ancient Near Eastern cubits. The royal cubit used in Egypt and Phoenicia was 0.524 meters. The Trilithon blocks measure 19.6 meters, by 4.34 meters by 3.65 meters. Those numbers don't divide evenly into Roman feet, they divide into cubits. Roughly 37 royal cubits long by 8 cubits high by 7 cubits deep. That suggests non-Roman design. The Roman temple on top uses Roman measurements. The columns are 19.9 meters high. That's 67 Roman feet. The spacing between columns follows Roman proportions, but the foundation doesn't. It's like two different projects. Two different cultures, one on top of the other. And here's what makes it interesting. The T-shaped podium beneath the Trilithon matches Herod's work in Jerusalem. That's confirmed. Herod ruled Judea from 37 to 4 BCE. His engineers were the best in the region, trained in Roman and Near Eastern methods. If anyone could have built the Baalbek foundation, it was them. But Herod's work at the Temple Mount stopped at 520 tons. So either Baalbek was built before Herod and he copied the design, or Herod built the smaller foundation blocks and left the Trilithon alone because it was already there. Both scenarios point to pre-Roman construction. Major quakes hit in 551 CE, 759 CE, 1837 CE, 1956 CE. Each one damaged structures across the region. The Roman columns at Baalbek fell multiple times. Only 6 remain standing today out of 54. The Temple of Bacchus, next door, lost its roof. Walls cracked, decorative elements tumbled, but the Trilithon didn't move, not 1 millimeter. The 3 800-ton blocks are still locked in place exactly where they were 2,000 years ago. No mortar, no pins, no tie rods, just weight and friction. And precision. The beveled edges create a mechanical lock. The weight creates compression. The friction coefficient for dry limestone on limestone is around 0.6. That means each block resists sliding with a force of 480 tons horizontally. You'd need more force than the block weighs to slide it. Earthquakes don't generate that much lateral force at ground level. They might at height, but not at the foundation. So the Trilithon is effectively earthquake-proof, by design or accident. Either way, it works. Modern engineers use similar principles in base isolation systems for buildings and seismic zones, massive blocks on sliding pads that absorb shock. Baalbek's foundation does this naturally. The 24 350-ton blocks beneath the Trilithon act as the isolation layer. The Trilithon sits on top, adding weight and stability. The Roman temple sits on top of that. When an earthquake hits, the foundation absorbs and distributes the force. The temple shakes and falls. The foundation stays put. This level of seismic engineering shouldn't exist in the ancient world, not documented anywhere. Not in Roman texts, not in Egyptian papyri, not in Mesopotamian tablets, but it's there, built into stones that were supposedly moved with ropes and ramps and bronze chisels. The wood expands, the rock splits, copper or bronze chisels carve the channels, stone hammers pound the surface, documented everywhere. Egypt, Greece, Mesopotamia, Rome. But here's the issue. The scale doesn't match. The wedge slots at Baalbek are massive, 15 to 20 centimeters across. That's 6 to 8 inches. Normal wedge slots are 3 to 5 centimeters. The depth is also wrong. Baalbek slots go down 40 to 50 centimeters. Normal slots are 10 to 15 centimeters, so either they used massive wedges, which means massive hammers, which means massive force, or something else. Graham Hancock and other researchers have pointed to industrial-looking marks on some stones. Straight cuts, uniform depths, no variation. Like a saw, but not a hand saw, something bigger, something that could maintain a straight line across meters of cut without deviation. Modern stone saws use diamond wire or carbide blades. Ancient equivalents would be bronze saws with quartz sand abrasive. That's documented. The Egyptians used it. But only on small stones, statue blocks, obelisk sections, not multi-ton foundation blocks. The effort required to saw through 19 meters of limestone with a bronze blade and sand would take years, decades maybe, for one stone. Multiply that by the 6 megalithic blocks at Baalbek, plus the 24 foundation blocks, plus all the smaller stones in the temple complex. The timeline doesn't work. The Romans built the temple in less than a century. That's confirmed. The megalithic platform would have taken longer using documented ancient methods. Unless the platform was already there, then the timeline works. The transport route mystery. 900 meters from quarry to temple site, uphill. The quarry sits lower in elevation. The temple platform is at the hill's summit. That means lifting. The standard theory uses rollers, wooden logs under the stone, teams of men pulling ropes, an earthen ramp built up to the platform level. The math says 512 workers with 40 capstans could move a 557-ton block 18 meters up at 20% grade. That's from Jean-Pierre Adams' 1994 analysis. Extrapolate to 800 tons. You need 800 workers. Minimum, maybe more. That's manageable, barely. But here's the problem. The terrain between the quarry and temple site isn't flat. It's broken. Bedrock outcrops, wadis, natural drainage channels. can't roll a log over bedrock. You have to prepare the surface, level it, fill the gaps, create a continuous path. That requires moving earth, lots of earth, cubic meters of fill to create a 900-meter ramp wide enough for an 800-ton stone. Evidence of this should exist. Compacted earth layers, stone rubble fill, traces of wooden rollers, ancient ramp foundations. Roman engineers left evidence everywhere else: roads, aqueducts, bridges. Their construction debris is archaeologically visible. But at Baalbek, nothing. No ramp remnants, no roller tracks, no compacted earth path. The ground between the quarry and temple is archaeologically clean. That's a problem. Either the evidence was completely removed, which is possible but unlikely, or the transport method left no trace, which implies something different from rollers and ramps. Dragging, maybe, but dragging 800 tons through dirt creates a trench, a scar. Those last for millennia in the archaeological record. Ice roads, maybe. But Lebanon doesn't freeze. The Bekaa Valley gets cold winters, but not sustained below 0 temperatures. Not enough for ice thick enough to support 800 tons. So what moved them? The hexagonal court, added by Emperor Philip the Arab around 247 CE, was meant to have more decoration. Column capitals were left rough-cut. Foundation stones for additional structures were prepared but never placed. The quarry stones were carved but never moved. Then construction stopped. Why? The usual answer is money. Building temples is expensive. Or priorities shifted. Constantine converted Rome to Christianity around 313 CE. Pagan temples fell out of favor. Resources went to churches. That explains why later construction stopped. But it doesn't explain why the largest stones in the quarry were never moved. Those were carved early, probably in the first phase around 16 BCE when the project started. That's a century before Philip the Arab, 2 centuries before Constantine. So if the stones were ready, why didn't the first wave of builders use them? The stone of the pregnant woman was meant for the temple. That's the assumption, but maybe not. Maybe it was carved for something else, something that never got built or got abandoned before the Romans arrived. The forgotten stone was only discovered in 2014, buried under dirt and rubble. It wasn't visible from the surface. Someone covered it, deliberately or naturally. Either way, it was out of sight. If the Romans didn't see it, they wouldn't have known to use it. But the stone of the pregnant woman is obvious. It's been sitting there for 2,000 years, at minimum visible to anyone who visits the quarry. Roman engineers would have seen it, they would have considered it, and they chose not to use it. That implies a decision. Either it was too heavy, or it was cracked. Or it wasn't needed, or it wasn't theirs to move. That last option is the interesting one. What if the megalithic stones were sacred, off limits, inherited from an earlier culture that the Romans respected or feared? That would explain the silence, the lack of records, the careful building on top of existing foundations. The Romans incorporated local cults into their pantheon. They renamed gods, but kept the worship sites. Baalbek was Phoenician before it was Roman, dedicated to Baal-Hadad and Astarte. The Romans called them Jupiter and Venus. Same gods, same site, maybe same foundation. Just don't mess with the old stones, build on top, but leave them alone. Aligned to within fractions of a degree. Over 60 feet of combined length. That level of precision requires surveying, measurement, reference points. The Romans had those tools. The groma for right angles, the chorbates for leveling, the dioptra for distance sighting, all documented. But using those tools to place an 800-ton stone, that's different. You can't just lower it into position and adjust. Once it's down, it's down. The weight makes fine-tuning impossible, so the placement has to be right the first time. That means knowing exactly where the stone will settle, calculating the compression of the foundation below, accounting for the stone's center of gravity, predicting how the edges will seat against adjacent blocks. This is advanced engineering, possible with modern computer modeling, difficult with ancient methods, not impossible, but difficult, and error-prone. Yet there are no errors, no gaps, no misalignments, no signs of grinding or chipping to force a fit. The stones were set once, and they were set perfectly. That implies either extreme skill or multiple attempts. The skill explanation requires a level of knowledge that should be documented somewhere. The multiple attempts explanation requires multiple stones. Practice runs, failed blocks discarded and replaced. There's no evidence of either, no written records of the methods, no discarded stone blocks in the quarry, just the 6 massive stones, 3 in place, 3 on the ground, and silence. Modern laser scanning in 2015 measured the Trilithon alignment. The blocks deviate by less than 2 millimeters over 19 meters. That's 0.01% error. For comparison, modern construction standards for concrete foundations allow 5 millimeters per meter. The Trilithon is 50 times more accurate, achieved with tools that shouldn't be capable of that precision by people who left no trace of how they did it. They found pottery dating to the Neolithic period, 9000 BCE, Bronze Age sherds from the 3rd millennium BCE, Persian pottery from the 6th to 4th centuries BCE with cuneiform writing, Roman coins, Byzantine mosaics, Islamic fortifications. Every layer of history is there, except the one that explains the Trilithon. In 2014, they found the Forgotten Stone, 1,650 tons. The largest cut stone in human history, sitting in the ground where it was carved. Never used, never moved, never explained. The dig also uncovered evidence of pre-pottery Neolithic bee settlement at the temple site. That dates to 8,500 BCE. 10,000 years ago, someone lived there, built there, worshipped there, long before Phoenicians, long before Romans, long before anyone we can name. The tell beneath the Jupiter temple has 11,000 years of continuous occupation, every century stacked on top of the last, and at the bottom. At the oldest layer, there are hints of megalithic work, foundation stones cut and placed in an era when humans were supposed to be hunter-gatherers living in mud huts. But someone at Baalbek was cutting multi-ton blocks with precision that matches Roman engineering, or exceeds it. That's the part no one wants to confront. The possibility that the Trilithon isn't Roman, isn't Phoenician, isn't from any culture we recognize, that it's older, a leftover from a time we don't understand, built by people who had knowledge we've lost, or never had. The Romans built 3 massive tunnel-sized corridors through the platform. Those are documented, visible, but the radar showed more: smaller passages, irregular spaces, possibly natural, possibly carved, leading deeper into the tell, unexplored, unstable, off-limits. What's down there? No one knows. The Lebanese government limits excavation. The site is a UNESCO World Heritage location since 1984. Preservation takes priority over exploration. So the passages remain sealed, the chambers stay hidden, and the questions pile up. Why build a foundation with internal passages? The Roman tunnels make sense. They allow access for maintenance, drainage, structural inspection. But the deeper voids, those don't fit our Roman construction practice. They fit something else. Storage, maybe, ritual space, or the remnants of an earlier structure. One that the Romans built over, incorporated, hid. Either way, it suggests layers, complexity, a history more tangled than the simple story of Rome building a temple in Lebanon. Cranes require massive lifting beams, wood thick enough to support the load. The largest ancient crane on record was built in Egypt for obelisk work. It lifted 300 tons using multiple pulley systems, doubling that to 600 tons. Maybe, but 800 tons breaks the system. The beam would snap, the ropes would tear, the whole rig would collapse. Ramps work for sliding heavy objects. But the Trilithon blocks are 20 feet above ground. A 20-foot ramp to lift 800 tons requires a shallow grade. 1% maybe, 2% maximum. That means a ramp over 1,000 feet long, with massive width to support the stone, and structural integrity to prevent collapse under load. The volume of earth needed is enormous. Where did it go? Ramps leave evidence, fill layers, compacted zones, post holes from support timber. At Giza, the remains of ramps are visible in the quarries and around the pyramid bases. At Baalbek, nothing. Levers could work. Mechanical advantage multiplies force. A 10-meter lever with a 200-kilogram counterweight gives you a 20-to-1 advantage. But 800 tons is 800,000 kilograms. You'd need 40,000 kilograms of counterweight, 88,000 pounds. Where do you get that? And how do you build a lever strong enough to handle it? Wood breaks, stone cracks, bronze deforms. There's no material in the ancient world that could serve as a lever for this application. So what did they use? But it took months of preparation and dozens of workers. Scale that to 800 tons. You're looking at years of effort per stone, multiple teams, rotating shifts, massive resource investment. Is it possible? Yes. Barely. Is it documented at Baalbek? No. The archaeological record shows no signs of the infrastructure needed for this type of operation. No worker camps, no tool caches, no evidence of the massive deforestation required for rollers and ramps. The Bekaa Valley was forested in antiquity. Cedar, oak, pine. Roman construction used local timber extensively, but moving the Trilithon stones would have required thousands of trees. The forest would have been stripped. That leaves evidence: stump fields, charcoal layers, erosion patterns from sudden deforestation. None of that appears in core samples or soil analysis around Baalbek. The valley shows gradual agricultural clearing over millennia, not sudden industrial scale logging, so either the method used different materials, or it happened before the forest was there, or it happened so carefully that no trace remains. None of those options fit standard ancient engineering. Lebanese University archaeologist Janine Abdulmasih was cleaning rubble near the stone of the pregnant woman when she found markings. Not tool marks, symbols, carved into the stone's upper surface, covered by centuries of dust and debris. The symbols were simple: lines, dots, arrangements that didn't match Roman numerals or Latin letters or any known ancient script. The markings were photographed, catalogued, sent to specialists in Phoenician. Akkadian, Egyptian, Hittite, no matches. The symbols remain undeciphered, but their presence suggests intention, communication. Someone carved those marks for a reason, to track the stone, to claim it, to mark it as sacred, or to label it for a construction project that never happened. The discovery was published in the bulletin of the German Archaeological Institute's Lebanon project in 2022. The paper notes the symbols but offers no interpretation, just documentation. Because without context, symbols are just shapes. They could mean anything or nothing, but they're there, on one of the largest stones ever quarried, carved by someone who knew the stone was important and then left it behind. Stones too heavy to move with ancient technology, precision too exact for hand tools, transport routes that leave no trace, Roman silence on their greatest engineering achievement, weathering patterns that predate the temple, measurement systems that don't match Roman standards, seismic engineering that shouldn't exist, tool marks that suggest industrial scale equipment, undeciphered symbols carved by unknown hands, and beneath it all, 11,000 years of human presence at a site that keeps revealing older layers, deeper foundations, earlier construction. The Trilithon isn't the beginning, it's what survived, what remains visible, the tip of something larger, something buried under 2,000 years of Roman glory and 10,000 years of accumulated history. Someone built it, someone who had the knowledge, the tools, the reason, and then vanished, leaving only stones. Silent, massive, perfect, and impossible to explain. The answer isn't in Rome, it's beneath Baalbek, waiting in sealed chambers and unexcavated layers, in symbols we can't read and methods we can't replicate, until someone digs deeper, until the passages are explored, until the tell gives up its secrets. The Trilithon stands, 800 tons each, placed with millimeter precision, 2,000 years ago, or older, by people we can't name, using methods we don't understand, for reasons that died with them. That's not a mystery, that's a message, and we still don't know how to read it.